Question 1. High availability for relational databases. Scenario: a fintech startup needs a MySQL database that automatically fails over within seconds during an AZ outage while maintaining transactional consistency. Which AWS service should they use? Options: A. Amazon RDS Multi-AZ. B. Amazon Aurora with read replicas. C. Amazon DynamoDB Global Tables. D. Self-managed MySQL on EC2. Correct answer: A. Amazon RDS Multi-AZ. Why it's correct? Synchronous replication. RDS Multi-AZ uses synchronous replication to a standby instance in another AZ. Transactions are committed simultaneously to both instances, zero data loss. Automatic failover. AWS handles failover automatically, RTO 2 minutes. DNS reroutes traffic to the standby. Transactional consistency. Guarantees ACID compliance after failover. Why other options are wrong? B. Aurora read replicas. Asynchronous replication, risk of data loss. Manual promotion required, RTO 5 mins. C. DynamoDB Global Tables. No SQL, incompatible with MySQL. Eventual consistency, not ACID. D. Self-managed MySQL on EC2. Manual setup, slow RTO 30 mins. Technical deep dive. Key details. Standby instance is fully provisioned. Dedicated network link between AZs. Real-world analogy. Multi-AZ equals hot standby generator, instant failover. Aurora read replicas equals backup batteries, delay. Exam tip. Automated failover plus relational database equals RDS Multi-AZ, 99% of the time. Question 2. Cost optimization for batch processing. Scenario: a video rendering company runs batch jobs every night for 6 hours. Jobs can restart if interrupted. Which compute option minimizes costs? Options: A. On-demand instances. B. Spot instances. C. Reserved instances, 1-year term. D. Dedicated hosts. Correct answer: B. Spot instances. Why it's correct? Spot instance mechanics. Up to 90% discount vs. On demand. 2-minute warning before interruptions. Use case fit. Jobs are interruptible and time flexible. Can checkpoint progress, e.g., save to S3. Why other options are wrong? A. On demand. Most expensive option. C. Reserved instances. Requires long-term commitment. Overkill for nightly jobs. D. Dedicated hosts. For licensing compliance, not cost savings. Technical deep dive. Spot fleets. Combine spot and on-demand for reliability. Spot blocks. Pay extra for uninterrupted runs, equals 6 hours. Exam tip. Spot instances aren't just for cost savings, they scale to tens of thousands of instances for big data workloads. Question 3. Securing temporary S3 access. Scenario: a serverless app needs to grant a Lambda function temporary read access to an S3 bucket. What's the most secure method? Options: A. Embed IAM user access keys in Lambda environment variables. B. Attach an IAM role to the Lambda function. C. Generate S3 pre-signed URLs. D. Make the S3 bucket public. Correct answer, B. IAM role. Why it's correct? IAM role mechanics. Temporary credentials via AWS STS, auto-rotate/expire. Enforces least privilege, e.g., read-only access. Lambda integration. Native role attachment. AWS handles credential management. Why other options are wrong? A. Embed access keys. Security risk, exposure via logs/repos. Manual rotation required. C. Pre-signed URLs. Only for specific objects, not bucket access. D. Public bucket. Violates AWS security best practices. Technical deep dive. IAM roles versus resource policies. Roles, attached to AWS services, Lambda, EC2. Bucket policies, for cross-account access. Real-world analogy. IAM roles equals temporary keycard. Access keys equals duplicated house key, risky. Exam tip. For temporary access, always prefer IAM roles over keys. For cross-account access, use bucket policies or STS assume role. Question 4. Real-time data streaming. Scenario: a social media app needs to ingest 100,000 messages/SEC from global users, process them in real time, and retain data for 24 hours. Which service should they use? Options: A. Amazon SQS. B. Amazon Kinesis Data Streams. C. Amazon MQ. D. Amazon SNS. Correct answer, B. Kinesis Data Streams. Why it's correct? Kinesis Data Streams architecture. Shards, scale to 100,000 messages/SEC, 100 shards. Retention, 24 hours by default, extendable to 7 days. Ordering and durability. Strict ordering within shards. Critical for time series data. Why other options are wrong? A. SQS. Throughput limit, 3,000 messages/SEC per queue. No retention, deletes after consumption. C. Amazon MQ. For legacy apps, MQTT/AMQP. Not designed for massive scale. D. SNS. Pub/sub service, no retention or ordered processing. Technical deep dive. Kinesis versus SQS. Kinesis, real-time analytics, dashboards, ML. SQS, decoupling microservices, order processing. Real-world analogy. Kinesis, conveyor belt, ordered, replayable. SQS, mailroom, process once and discard. Exam tip. Kinesis is the go-to for exam questions involving real-time analytics or replayable data streams. Question 5. Costly S3 storage misuse. Scenario: a company stores daily backup files accessed once a week for auditing. They use S3 standard. How can they reduce costs without changing access patterns? Options: A. S3 Intelligent Tiering. B. S3 Glacier Instant Retrieval. C. S3 Standard Infrequent Access, IA. D. S3 One Zone IA. Correct answer, C. S3 Standard IA. Why it's correct? Cost analysis. Standard, $0.023/GB/month. Standard IA, $0.0125/GB/month, 40% cheaper. Weekly access makes retrieval fees negligible. Key benefit. Maintains 11 nines durability across 3 AZs. Why other options are wrong? A. Intelligent tiering. $0.0025/GB/month monitoring fee. Less cost-effective for small datasets. B. Glacier instant retrieval. 90-day minimum storage duration. Weekly access triggers penalties. D. One zone IA. Single AZ storage, riskier for backups. Technical deep dive. Lifecycle policies. Automate transitions to standard IA after 30 days. Cost calculation example. 1 TB stored and 1 TB retrieved monthly. Standard IA, $12.50 plus $10 equals $22.50. Standard, $23, no retrieval fee. Exam tip. Glacier is for archival, accessed yearly. Use standard IA for infrequent but regular access. Question 6, Event-driven scaling notifications. Scenario, an e-commerce application needs to trigger a Lambda function every time an auto-scaling group scales out. Which service enables this? Options. A. Amazon Event Bridge, formerly CloudWatch Events. B. AWS CloudTrail. C. Amazon SNS, Simple Notification Service. D. AWS Config. Correct answer, C. Amazon SNS. Why it's correct? Auto-scaling and SNS integration. Auto-scaling sends notifications to SNS topics. Lambda subscribes to topic for instant triggers. Key benefits. Fully serverless workflow. Real-time event processing. Why other options are wrong? A. Event Bridge. Requires manual event rule configuration. B. CloudTrail. Logs events but doesn't trigger in real time. D. AWS Config. Tracks compliance, not operational events. Technical deep dive. Implementation steps. 1. Create SNS topic in auto-scaling group. 2. Subscribe Lambda to the topic. Message format. JSON payload with instance details. Lifecycle state changes, launch/terminate. Real-world analogy. SNS equals factory loudspeaker announcements. Lambda equals robots reacting to announcements. Exam tip. For auto-scaling event notifications, SNS is the native solution. Event Bridge is for complex event routing across services. Question 7, Low-latency networking for HPC workloads. Scenario, a high-performance computing, HPC, application requires sub-millisecond latency between EC2 instances for parallel processing. Which placement strategy should you use? Options. A. Spread placement group. B. Cluster placement group. C. Partition placement group. D. Regional placement group. Correct answer, B. Cluster placement group. Why it's correct? Cluster placement group mechanics. Same rack placement, 1 millisecond latency. High throughput, up to 100 Gbps. HPC optimization. Tightly coupled nodes for parallel processing. Enhanced networking, ENA/SRIOV support. Why other options are wrong? A. Spread placement group. Multi-rack/AZ placement, 10 ms latency. C. Partition placement group. For fault-isolated distributed systems. D. Regional placement group. Non-existent AWS service, distractor. Technical deep dive. Supported instance types. C5N, I3N, P4D, enhanced networking. Key limitations. Single AZ deployment only. Requires instance type compatibility check. Real-world analogy. Cluster group, team at same table, instant talk. Spread group, team across buildings, delays. Exam tip. Cluster placement group is the only option when the question mentions sub-millisecond latency or HPC workloads. Question 8. Disaster recovery strategy with cost constraints. Scenario: a startup wants a disaster recovery strategy with minimal costs but an RTO of less than 4 hours. Which approach should they use? Options: A. Pilot light strategy. B. Warm standby strategy. C. Multi-site active-active strategy. D. Backup and restore strategy. Correct answer: A. Pilot light strategy. Why it's correct? Pilot light mechanics. Critical components always running. Non-critical components launch on demand. Cost vs RTO trade-off. RTO 1 to 4 hours. Minimal infrastructure costs. Why other options are wrong? B. Warm standby. Scaled down full environment. Higher costs than pilot light. C. Multi-site active-active. Full capacity in both regions. Most expensive option. D. Backup and restore. RTO greater than 24 hours. Cheapest but slowest. Technical deep dive. Implementation tools. AWS CloudFormation/Terraform templates. Pre-stored AMOS/container images. Real-world analogy. Like keeping car engine idling. Ready to go quickly when needed. Exam tip. When you see minimal cost plus RTO 4 hours in a DR scenario, pilot light is almost always the right answer. Question 9. Security groups versus NACL's behavior. Scenario: which statement about security groups is false? Options: A. They act statefully. B. They block all inbound traffic by default. C. They can restrict outbound traffic. D. They evaluate all rules before allowing traffic. Correct answer: D. They evaluate all rules before allowing traffic. Why it's correct? False statement. Security groups do not evaluate all rules cumulatively. Instead, they evaluate rules independently, and if any rule allows the traffic, it is permitted. For example, if Rule 1 allows inbound traffic on port 80 and Rule 2 denies inbound traffic on port 80, the traffic will be allowed because the allow rule takes precedence. Why others are true? Correct statements. A. They act statefully. Security groups are stateful firewalls, meaning that if an inbound rule allows traffic, the corresponding outbound response is automatically allowed even if there's no explicit outbound rule for it. B. They block all inbound traffic by default. By default, security groups block all inbound traffic unless explicitly allowed. Outbound traffic, however, is allowed by default. C. They can restrict outbound traffic. You can add explicit outbound rules to deny or restrict traffic from leaving your instance. Technical deep dive. Stateful behavior. Security groups remember the state of connections. For example, if an inbound request is allowed on port 443, the outbound response is automatically permitted without requiring a separate rule. This contrasts with network ACLs, NACLs, which are stateless and require separate rules for both inbound and outbound traffic. Rule evaluation logic. Security groups only need one allow rule to permit traffic. NACLs, on the other hand, evaluate rules sequentially in ascending order, rule number 1 first, then number 2, etc. Real-world analogy. Think of a security group as a doorman at a club who checks each person against a list of allowed names. If your name is on the list, you're in. NACLs are like airport security, they check both your entry and exit thoroughly. Exam tip. Security groups use allow any logic, one allow rule permits traffic, while NACLs use deny any logic, explicit allows required in numbered rules. Question 10. Cost-effective reserved instances for steady-state workloads. Scenario: a company runs a steady-state workload 24/7 in US East 1. How can they minimize costs while ensuring consistent performance? Options: A. On-demand instances. B. Convertible reserved instances, 1-year term. C. Standard reserved instances, 3-year term. D. Spot instances. Correct answer: C. Standard reserved instances, 3-year term. Why it's correct? Standard reserved instances mechanics. 3-year term provides up to 72% savings. Locked pricing for predictable costs. Steady-state workload fit. Ideal for 24/7 continuous workloads. No need for flexibility. Why other options are wrong? A. On-demand instances. No discounts for long-term usage. B. Convertible RIS. Lower discounts, 54%. Unnecessary flexibility. D. Spot instances. Interruptible, 2-minute warning. Technical deep dive. Payment options. All upfront, max savings. Partial upfront, moderate savings. No upfront, least savings. Savings plans vs RIS. RIS offers slightly higher discounts. Real-world analogy. Like signing a long-term apartment lease. Exam tip. For 24/7 steady-state workloads, standard RIS, 3-year, always provide the highest savings. Convertible RIS are for when you need flexibility. Final recap of key concepts. High availability for relational databases, Q1. RDS multi-AZ equals automated failover, 2 minutes. Synchronous replication for zero data loss. Cost optimization for batch processing, Q2. Spot instances equals up to 90% discount. Ideal for interruptible workloads. Securing temporary S3 access, Q3. IAM roles equals most secure method. Never store keys in environment variables. Real-time data streaming, Q4. Kinesis equals ordered, replayable streams. 1 MB/sec per shard throughput. S3 storage optimization, Q5. Standard IA equals 40% cheaper than standard. Ideal for weekly access patterns. Event-driven architectures, Q6. Use SNS for real-time notifications triggered by scaling events. Event Bridge adds more flexibility but requires extra configuration. Networking placement strategies, Q7. Cluster placement groups equals low latency, 1 millisecond, for tightly coupled HPC workloads. Spread placement groups equals fault tolerance by isolating instances across racks/AZs. Disaster recovery strategies, Q8. Pilot light equals minimal cost plus moderate recovery time, 4 hours. Backup and restore equals cheapest but slowest recovery, greater than 24 hours. Security groups vs NACLs, Q9. Security groups equals stateful, evaluate rules independently. NACLs equals stateless, evaluate rules sequentially. Reserved instances for cost optimization, Q10. Standard RIS provide maximum savings, 72%, for predictable workloads. Spot instances are great for cost savings but unsuitable for steady-state applications. Good luck!